Hello to everyone. Welcome to Further Mathematics. We'll be doing differential equations today, and we are answering June 2021. And differential equation is the first question. So the first question says that find the complementary function of the differential equation d squared y over dx squared plus 4 dy dx plus 4y equals to e to the power minus 2x. So when solving this, the first thing we need to do is we need to have it in mind that to get our complementary solution, we need to develop our characteristic equation. And from here we see that our characteristic equation is n squared plus 4n plus 4n plus 4 equal to 0. And from here we're going to look for the roots of this equation. So from here we're looking for factors of 4 that when we add, so we have 2 and 2, therefore when you add 2 and 2 gives us that, so we have n plus 2 all that squared to be equal to 0. So the first thing we've noticed is that we have repeated roots because n1 is equal to n2, which is equal to n, and this is equal to minus 2. Therefore our complementary solution y complementary will simply be equals to a plus bx e to the minus 2. So actually this is the solution of the first equation. So we've looked for the complementary solution here, and we've kept it in the form y equals to f of x. Now after looking for the complementary solution,
I should have seen it coming. It didn't take long after the fall of the Umbrella Corporation for their bioweapons to end up in the hands of terrorists. A new era of bioterrorism descended upon vulnerable countries, shifting the balance of power throughout the region. People in the destabilized areas soon feared another incident like Raccoon City was inevitable. As panic spread, governments of the world turned to the Global Pharmaceutical Consortium, which formed the anti-terrorism unit BSAA. Operatives of the BSAA were sent to infiltrate and neutralize bioterrorist hotspots, restoring safety and stability to various regions around the globe.
Welcome to Africa.
we're asked to hence find the particular integral and the general solution in the form y equals to f of x. Now after getting our complementary solution, to get our particular solution, then we have to take note that our complementary solution or our particular solution is part of our complementary solution. So if we look at e to the minus 2x, we notice that it's also e to the minus 2x here. So this is going to pose a problem if we're just going to look at our particular solution normally. So here the particular solution will have a special consideration. So we're going to have y particular to give us a. So normally we were supposed to have a e to the minus 2x, but now since our particular solution is part of our complementary solution, this is wrong. So we're going to have our y particular to be equals to ax e to the minus 2x. So that's our particular solution, and from here we look for the first derivative, look for the second derivative, and we substitute here and get the necessary values of a. So the first step we need to do is to look for the first derivative. Dy all over dx here will simply be equal to, now we're going to keep a e to the minus 2x constant and differentiate x. So normally we're going to have a e to the minus 2x. So we have that. Now plus, we're going to now keep ax constant and differentiate e to the minus 2x. We see that when we differentiate minus 2x, we're going to get minus 2. Therefore, we're simply going to have minus 2 there actually. So we're going to have minus 2 ax e to the minus 2x. So I've looked for our first derivative. Now to look for the second derivative, we can give this our second derivative a name. Let's just say equation 2, and we call this our equation 1. So now to look for the second derivative, d squared y all over dx squared will simply be, so now we're going to concentrate on these terms. So we have term 1 and term 2. Now looking at term 1, we see that the derivative of minus 2x is minus 2, so we are going to have minus 2a e to the minus 2x. So we are done with the first term, we are done with this. Now onto this, we see that if we factor out minus 2, we're simply going to get exactly what we have above here. So this, let me just show it this way. So if we factor out our 2, we notice that this is exactly the same as this above here. So what does that mean? It means the derivative of this function when we factor out minus 2 will simply be equation 2. So I'm going to write here, I'm going to simply write here a e to the minus 2x minus 2 ax e to the minus 2x. So we have that. All we need to do now is to simplify this, and when we simplify, we're going to have our d squared y all over dx squared will simply be equal to, now this and these are similar, therefore we're going to add this, so it will be minus 4a e to the minus 2x, and when we open a bracket here, plus 4ax e to the minus 2x. So we have, this is our equation 3. So if we take our equation 1, equation 2 and equation 3 and put in equation star, then we're going to get our value of a. So we have d squared y over dx squared. So we're going to copy this. So we're going to copy this, minus 4a e to the minus 2x plus 4ax e to the minus 2x. So that is it, plus 4 dy dx plus 4 dy dx. So we're going to have plus 4 in bracket, our dy dx is this, so a e to the minus 2x, so it will be a e to the minus 2x minus 2 ax e to the minus 2x. So we have this. Now looking at it, the equation star again, plus 4y, now plus 4y plus our 4y plus 4y, but our y, which is our particular solution, is ax e to the minus 2x, so it should be ax e to the minus 2x. So this will simply be equal to e to the minus 2x. So e to the minus 2x. So we have this. Now when we look at it critically, you see that e to the minus 2x is common throughout. So we're going to kind of like just cancel this out. E to the minus 2x is common, so cancel this e to the minus 2x, and on the right hand side we'll be left with 1. So now we're going to separate or bring together like terms. All terms in a should be written on one side, and all terms in x should be written on the other side. So here we're going to factor out all the constants. So if we bring all the constants, we're going to see here that we have minus 4a here and 4a here. So this will actually go away with that, and that will go away with that, and we have 4ax here and minus 8a here. So basically when we look at this, we have 4ax minus 2ax, so this is going to give us 0. So we have 4ax minus 8ax plus 4ax, so equal to 1. So we see here that 0 should be equal to 1. Very good. This is very interesting. This is very interesting. Let's just say 1. This is very interesting. Now let's go back to our original equation. We saw that since our particular solution was part of the complementary solution, we couldn't take our particular solution to be this case. Now we've gone ahead to take y particular to be ax e to the minus 2x, and it's cancelling out, showing that even y p e ax e to the minus 2x will not give us the solution. Therefore, we're going to step ahead by taking our y particular to instead be ax squared e to the minus 2x. So basically this is what we're going to be dealing with from now. Good.
My name is Sheva Alamo.
Chris Redfield.
Your reputation precedes you, Mr. Redfield. It's an honor.
Just Chris, thanks. So you'll be accompanying me to the destination?
Yes. Tensions are running high ever since the change in government.
I'll bet. Intel says it's a haven for terrorists now.
And I'm not going to be happy to see an American, BSAA or not. That's why I'm your partner. Help put them at ease.
Well, I'm sure you'll do just fine. Partner.
You okay?
Yeah, sorry. It's nothing. Let's go. Casualties continue to mount over the long years I've struggled. More and more, I find myself wondering if it's all worth fighting for. Maybe one day, I'll find out.
Hey, huyo wingine anafanya nini hapa?
You don't have to get touchy. Let's go.
There is one thing I do know. I have a job to do, and I'm gonna see it through.
So now, after seeing that our y particular should be ax squared e to the minus 2x, we're going to go ahead to look for our first derivative, our dy dx, which will be equals to here. So we're going to have, we're differentiating x squared, so it will be 2ax e to the minus 2x. Now plus, not plus actually, minus, because the derivative of minus 2x is minus 2, so minus 2ax squared e to the minus 2x. So this is our first derivative. Now what actually happened above here, if you watch part of my videos, that is part 3 or part 4 of the video series under differential equations, then you will know that whenever this happens, then you need to increase the power of x in your particular solution, so that in an exam when you're faced with something like this, it will be very easy for you to handle. Now if we look for our second derivative, d squared y all over dx squared equals to this, then now we have to keep x constant, so we're keeping this constant, right? We're differentiating this, sorry, so we're simply going to have 2a e to the minus 2x, now plus, not plus actually. You can write plus and then you put minus 4ax e to the minus 2x. So minus, now we're here, so we're going to be differentiating x squared, so it will be, when we differentiate x squared, we're going to have 2x, so it will be minus 4ax e to the minus 2x. And now we're going to keep this and we'll be differentiating this, so plus 4ax squared e to the minus 2x. Great. So this is our second derivative, and we're simply going to put this in our original equation above here, in our original equation here. So our d squared y, we simply need to copy this function. So to copy this function here,
This is Kirk. Chris, Sheva, can you read me?
Chris here. Coming in loud and clear, Kirk.
Yes, we read you.
There's a black market weapons deal going down in Kijuju. That's where Irving will be. Alpha team has already infiltrated the area, and you will be going in as backup. Rendezvous with your contact at the butcher's shop. You can gear up and get...
Na wasaliti wote walete kwa wenye mamlaka. Ukipata
Good, you're both here. Come. You too. This way. But maybe because of the new government, the people around here are a little on edge. You should do what you came here to do and go home.
Yeah, they really roll out the red carpet for us Americans.
I have your weapons for you here. Check them. Grab your weapons. The operation's already started.
we're going to have 2a e to the minus 2x plus minus 4ax e to the minus 2x minus 4ax e to the minus 2x plus 4ax squared e to the minus 2x. So now plus, we have plus 4 dy dx plus 4 dy dx. So plus 4 in bracket, our dy dx should be 2ax e to the minus 2x minus 2ax squared e to the minus 2x. Voila. So plus, so if we look at that, plus 4y. So if we look at that, plus 4y plus 4y, our y is ax squared e to the minus 2x. So this will give us equals to e to the minus 2x. So we see here that minus 2x is common, so it's going to cancel out, and we're simply going to simplify our value. So e to the minus 2x is out. So now we have 2a. We're finished with this. Want to combine the terms. Minus 4 so this was the only constant term. Okay, that's the only constant term there. So if we look at this, let's bring the terms in x. So this is the only constant term. Now the terms in x, so it will be plus minus 4a. This is in x, so we're going to factor out that side, and minus 4a. We're done with this. Plus here we have plus 8a plus 8a plus 8a. So we're also done with that. And now all that x. So we're going to bring now our terms in x squared. So our terms in x squared will be 4a here, and minus 8a, we're done with that, and plus 4a. Now all that x squared equal to 1. So it's very clear, this is going to cancel. This will give us 0. And if we look at this, the terms in x, on the right hand side we might say we have 0x here, so that if we equate our coefficient, or if we compare the coefficients, we see that 2a should be equal to 1. So this implies that our a simply is a 1/2. So this is our value of a. Now if you look at this here, it's also going to cancel out. So our value of a is a half. So from here we see that our particular solution will simply be equals to ax squared e to the minus 2x. Our a is a half, so we have a half x squared e to the minus 2x. So this is our particular solution. We know that to get our general solution, y general will simply be y particular plus y complementary, or y complementary plus y particular. We already saw that our complementary solution is ax plus b. So finally we're going to get our y general to be equals to a plus bx e to the minus 2x. Now plus our complementary solution plus a half x squared e to the minus 2x. So we have this, and here is our solution, and for differential equation June 2021. So for those interested in getting more videos, please, you can leave that in the comment section. You can just write anything, your worry, the topic, and all of that. So if this video was helpful in one way or the other, please, you can just leave a like, and see you guys in the next video.
Destination coordinates?
Town square's up ahead. Go through there. Alpha team's waiting at the deal location.
Good.
What do you know about Ouroboros?
Mostly just rumors. Something about visions of a doomsday project.
Doomsday sounds about right, and apparently it is no rumor.
You're kidding, right?
You must find a man named Irving. He is our only lead. And be careful out there.
Remember, we're a team. Whatever happens, we stick together.
Don't worry. I may not be as big as you, but I can still hold my own.
hear that? It came from that building. What the hell just happened?
They didn't move like any zombies I've ever seen.